Okay, let's take a look at review problem number 1. The first review problem asks us to first show one of these De Morgan's laws, that the negation of P and Q is the same as not P or not Q. And the way that we'll do this is with a truth table. So first we'll make the truth table for P and Q. And we'll work on the left side here. First we'll get P and Q, and then the negation of P and Q. So that'll be the that'll be the steps to get the left-hand side. Then on the right-hand side, we'll get not P, we'll get not Q, and then finally we'll get not P or not Q. And the objective will be to show that the entries in this column are the same as the entries in this column, and that will show that the two statements are equivalent. So the four possibilities for P and Q: true, 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 false, false, true, and false, false. Those are the possibilities for P and Q. P and Q is true if both P and Q are true, and otherwise, if either one is false or both are false, then the conjunction is false. Next, to get the negation of P and Q, we'll take the negation of this column. So I have false, true, true, true. And so that will be the truth table for not the negation of P and Q. Next, let me switch pen colors. Let's get the right-hand side. So not P would be the negation of P, so that would be false, false, true, true, taking negation of the steps over here. Not Q would be false, true, false, true. And then if I take the disjunction of these two things, the disjunction is true as long as at least one of them is true. So false or false is false. False or true is true because at least one of them is true. True or false is true. And finally, true or true is true. And so we see that this column, these two columns are the same. And so that proves that the two statements are indeed logically equivalent. Okay, next we will show that, let me write down the statement, that P implies R or Q implies R is logically equivalent to P and Q implies R. Okay, this one involves three statements, or three propositions, P, Q, and R. And so I'll need to have a truth table with three columns at the start, P, Q, and R. To work on the left-hand side, I'll have P implies R and Q implies R. And then once I get those two things, we'll figure out P implies R or Q implies R. So that'll be the left-hand side. On the right-hand side, I'll first figure out what P and Q is, and then once I have that, I'll figure out P and Q implies R. So that'll be the truth table that I have for this problem. And this will be a fairly long truth table because I have three propositions, which means that I'll have 2 to the third, 8 rows to this truth table. So true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and finally false, false, false. Okay, so those are the 8 rows that I'll have for this truth table. Okay, first off, P implies R. P implies R, the only way that is false is if the hypothesis is true and the conclusion is false. It is impossible for a true statement to imply a false statement. So P implies R, so I have T false here, so that's going to be false. Looking only at P and R, I have another true false here. And I'm not looking at the Q column, just true and false, that's false. All the others are going to be true. So true, 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 true. Next column for Q implies R. Once again, if the hypothesis is true and the conclusion is false, then the implication is false, otherwise it's true. So true implies false I see here, so that's false. And then true implies false is also here, so that's false. All the others are true. Okay, now I need to take the disjunction of these two columns. So if I see false or false, that's false. And I believe that is the only place that I see a false or a false. All the others, there's at least one true. So true or true, false or true or true. So all of these, there's at least one true. And so the only place where I have a false is on the second row there. Okay, next let's take a look at the right-hand side. So P and Q. That means I have to have both of these to be true. So true, true. So P and Q are both true. For all of these others over here, at least one of P and Q is false, and so these are all false. Okay, next we come to P and Q implies R. The only way that happens, the only way that this implication is false is if the hypothesis is true and the conclusion is false. So that only happens on one line here. True implies false. That's the only way that this becomes false. So that's false. All the others are true. And we see that these two columns are the same. And so that means that the two statements over here are indeed equivalent. Okay, third, let's take a look at the equivalence. P if and only if Q is equivalent to P and Q or not P and not Q. Now before we prove this, let's just talk about this one in words to see that it makes sense. P if and only if Q, that's saying P and Q are true at the same time or P and Q are false at the same time. So that's logically what we see here, so it makes sense. Let's establish this with the truth table. So P and Q are going to be my two columns. On the left-hand side, we just have the one implication, P if and only if Q. On the right-hand side, we've got a little bit of work to do. We have P and Q. We also have to get not P and also not Q so that we can figure out what not P and not Q is. Then once we have not P and not Q, I'll take the conjunction with this column, P and Q, or sorry, the disjunction with that column, P and Q, or not P and not Q. And again, the goal is to show that this column will be the same as this column. Okay, so true, 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 false, false, true, false, false. P if and only if Q is true if both P and Q have the same truth value. They're both true or they're both false. Otherwise, the if and only if statement is false. Okay, let's now start working on the right-hand side. P and Q is true if P and Q are both true. Otherwise, if at least one of them is false, P and Q is false. Okay, now let's start working on this part here. Not P goes false, false, true, true, taking the negation of this column. If I take the negation of this column, I get false, true, false, true. Okay, then if I take the disjunction, the conjunction of these two, the conjunction is true only if they're both true. So true and true makes true. All of these others, I have at least one false, and so these are false. So if I take the disjunction of these two columns, true or false is true. False or false is false. False or false is false. False or true is true. And these two columns are the same. And so therefore the statements here are indeed equivalent. Lastly, let's show the equivalence relation. P and Q is equivalent to not P implies not Q. Okay, let's do this with the truth table. So P and Q. So on the left-hand side, we'll worry about P and Q. On the right-hand side, I need to figure out what not Q is. Once I have not Q, I then will figure out what P implies not Q is. And then once I have that, I'll take the negation to get the negation of P implies not Q. Okay, so true, 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 false, false, true, false, false. Okay, take the conjunction. The conjunction is true if and only if they're both true. So there's the conjunction true, false, false, false. On the right-hand side, not Q will be the negation of this column. So false, true, false, true. P implies not Q. The only way that P implies the only way this is false is if the hypothesis is true and the conclusion is false. That appears here. True implies false. That cannot happen. All of the others are acceptable. So a true statement can imply a true statement, a false statement can imply a false statement, and a false statement can imply a true statement. So false, true, true, true. And then finally I take the negation of this column and I get true, false, false, false. And so these two columns are equivalent. And so that shows, or those two columns are the same, and that shows that these two statements are equivalent. Another way that this could have been done, just for the sake of completeness, this wasn't asked in the review problem. If I take not P implies not Q, by one of our rules that we established in class, this is the same as not the hypothesis or the conclusion. And then by De Morgan's laws, this is not the first and not the second. And by double negation, this is equivalent to P and Q. So that's the way this could have been done without using a truth table.